On our next page, we're going to find the inverse of these functions. We look here and we see an exponential equation. So to find the inverse, we switch the x and the y, and then we're supposed to solve for the y. This is exponential form. So the way to break apart exponential, or to get to that exponent, is to do a logarithm. So the log of the base, so the 8 goes in that location. Remember that the logarithm always equals whatever the exponent is. So it's log base 8 of x equals y. This is the natural log, ln. It always has a base of e. Notice that this is starting out to work with logarithmic form. So we're going to switch that. We're going to figure out what the exponential format is. So we're going to take the x and the y and switch those. So you look for the base, which is e. Remember, the logarithm always equals the exponent. So e to the x equals y minus 4. And then you add the 4 to the other side. And we have found the inverse. So we'll switch the x and the y. Well, this is exponential form, so I'm going to have to use a logarithm eventually. But first I'm going to subtract 7. And get the y by itself, the log base 4. Remember, a logarithm always equals the exponent of x minus 7. Here we have exponential form. So we're going to switch the x and the y. We'll have to write it as a logarithm with base 5 of x equals the exponent, which is y. Logarithms always equal the exponent. I can't say that enough. To find the inverse, we switch the x and the y. In this case, we have to subtract the 2. Now this is exponential form, so we need to write it as a logarithm for the inverse. And then our final one, this is logarithmic form, so we need to write it as an exponent. First we're going to interchange our x and the y. This is, the base is 11. The logarithm equals the exponent. And it equals the exponent.